Well, good evening, everybody. Assuming there's still somebody out there. Welcome again to the third instalment of Reloading Live. You must be really desperate to do this on a Friday evening by now. So in the last episode, we covered sizing cases, running through various dies, and getting your neck tension to the level that you need to grip the bullet and prepare your case for the next stages. So in this episode I'm going to cover what I would go through in the next phase of case preparation. If you remember, we've put a case through a sizing die. It has probably been lubed. If it was a full length sizing die, you need to put some lube inside and outside, which makes it a little bit sticky, a little bit tacky. You can feel the lube on the case. So bear that in mind when you start going through this process, but we'll come to cleaning that off shortly. The main thing I'm looking to do now is make sure that all these cases are under the maximum trim length. So if you remember, each case, this case 308 Winchester, has a maximum trim length. In this particular scenario, it's 2.015 inches or 51.18 millimeters. That's the spec of the chamber that's most likely been cut in your rifle, unless it was a custom rifle or it's been cut to a slightly different spec. Pretty much all SAMI or CIP spec chambers will be cut to this length to allow you to put a case in a little bit longer than this, but not much. They want you to make sure that your cases are under this length, so that this area doesn't expand into a tighter area of the bore or the lead of the rifle, where the rifling's been removed but the chamber size is a little bit bigger than the bullet. Easiest way to do this, there are a couple of tools that you can pick up, very reasonably priced. This packet here covers pretty much everything you need in terms of the cutter itself, the lock stud, which I'll show you in a second, primer pocket cleaner, and a chamfer tool, all in one pack, roughly about 12-14 pounds, something like that. And then you have a caliber specific case length gauge and shell holder. The shell holder screws onto the lock stud, and I'll show you one now. So that's the shell holder and the lock stud. Very simple. The case itself is slipped into the shell holder and lock stud is tightened, and that case is now held in the lock stud and can be trimmed to length. The cutter and cartridge specific case length gauge, two pieces. This screws into that. Obviously the cutter has four little teeth that allows it to trim the very top of the neck down to length. This cutter is a specific length. The manufacturers, in this case the same manufacturer as the die, knows that if you bottom that cutter out in this respect, it will cut anything over this length but nothing below. So it is a purely a safe way of doing it. You're not going to trim too much. Now, I don't know if you can hear, this is just taking a bit of material off the case. Now you can do this by hand. You can see some of the brass coming off now, and you'll start to see on the neck like that. It's removing material from the edge of the neck to make sure it's under the max trim length. There are various things you can get to make this process easier. There's a little wooden handle that has the cutter built into it, and it allows you to not get cramp in your hands, but by far the easiest way of doing this is to whack the shell holder in a cordless drill or of some description, and just allows you to do the same process. You can see all the brass coming off, and that's it done. It won't trim any more off because it's bottomed out. It's bottomed out, if you remember, through the primer pocket hole. If you push this case in like that, you can just see the lock stud primer pin pushing through the hole, and it's bottoming out on the flat surface of this lock stud and shell holder. Slapping it in the drill like that's the quickest way of doing it. You can whiz these cases off very, very quickly and get through 100 cases very easily. It's very straightforward to pull it off the shell holder. It just comes off with a quick undoing the ring there, and you can see it's left a nice uniform trim to that case. Now that's going to be sharp. You can feel if I run my nail up to the edge of that, it's got an edge to it, because obviously the cutter is a flat cutter. When it cuts through to the bottoming out point, it is squeezing brass inside and outside of the case neck. Now you could use it like that. It's not going to be a major problem. If you were to seat a bullet in that case now with a soft jacketed bullet, what you may find is that the edge of the case acts like a little chisel, and it can take off a strip of copper. Brass is obviously an alloy. It's a little bit harder than copper. A sharp edge like that will cut into the copper. It also creates an uneven surface, so you haven't got neck tension alone responsible for the grip on that bullet. You've got an edge, and it's something that's potentially quite sharp. So next stage in the process is the chamfering of the case. There are various other trimmers you can get. There are bench mounted ones that look like a mini lathe, and various other products that you can buy. Many of these are adjustable. In my mind, this is a safety precaution. I'm not trimming to a specific length other than I want to be below the max. If I wanted to go any further and maybe uniform all of the cases so that they've got exactly the same neck length with this tool, you are limited to what you can do. The easiest way to do that is file a little bit off the tip of this pin, and it will give you another length, but you will then be fixed to that length. And if you go too far, then clearly you're going to be taking too much material off the neck, and you'll have to throw all your brass away anyway. The bench mounted ones do have an element of adjustability. You can increase the length or decrease the length rather, and they have a very similar cutter. They still require the same process for chamfering the edge of the neck. So that's probably one of the most useful case conditioning tools you can have, and combined with this lock stud. The lock stud has a number of useful purposes as well, and I'll show you some of the quick ways of cleaning a case afterwards. So there's a trimmed case. I'll put it back in the drill. Now you can do this by hand. It's probably just as easy to do it by hand because it won't need a lot of material removed. The inside chamfer tool just has two little cuts in the cone there. If you put this into the neck and just turn it by hand, it will remove the sharp edge, and you'll get a nice little chamfer on the edge. If you do it in the drill, that's it, done. Same thing, this particular one, again from the same kit that all the other bits came in from Lee, has an inside cone as well. Same process. Give it a quick squiz, and there's now no edge on that, and you've got a nice trimmed case which has now got a little bit of a taper on each side of the neck, which will allow two things. One, it'll allow the bullet to go in more easily when you do get around to seating it, and secondly, you haven't got any sharp edges to snag on the inside of the chamber, or if you have a particularly tight chamber, that will cause an issue. That's one design that you can get for case chamfering, and here's another one here. This one by RCBS. It's been designed so that it'll cover everything from 0.17 right up to 0.45. It has a slightly different design. This one's more like the cutter than it is the Lee product, and then again it has three cutting teeth at the bottom. Same process. Case goes in there, and it's just enough to take the edge off the case. The only problem with these is if you put the case in at an angle, you can get slightly unusual angles on the chamfer. It's not a major problem. Ultimately, all you're looking to do is remove a little bit of that sharp edge and prepare the case for the next stage. So that's you all trimmed to length. Maybe you've done this in a batch, you've done all 100 or however many cases you're preparing. They're now all trimmed to length, they've been sized, we know they fit in the chamber, we've set our dies up so that they're perfectly aligned with your size of chamber. Now, these cases, you have primer pockets with varying degrees of carbon in them. This one I've already run a primer pocket cleaner through, and these two, they're not too bad. You would have no issues just banging in another primer and firing those again, but if you want to go the full hog and make sure that everything is squeaky clean and they're all the same in the way they look and in their size and shape and everything else, then you're going to need to clean those pockets. So in that packet of Lee case conditioning, you've got this little item, one end slightly fatter than the other. This for large rifle or large pistol primer pockets, and this one for small. They're all the same size. All of the cases that you're going to come across, whether it's standard deer stalking or target shooting cartridges, have the same size pockets, whether they be small or large. So all of the large ones, you buy your large rifle primers, it doesn't matter what brand they are, they should be the same size. I say should. As you go through these cases and fire them, these pockets can get slightly slack, something you'll feel when you're seating the primers in the next stage going down. So again, very straightforward. Dirty case, bit of carbon in there, primer pocket cleaner, give it a twist, and lo and behold, all the carbon comes out. It's pretty clean, and as far as I'm concerned, that's ready to go. There is one other tool that I use which is very advanced. It is a ice lolly stick. The thing I do like about this is if you push hard enough, this will flare up and you get quite a coarse brush, and it does the same thing, but it just seems to take a little bit more of the carbon off and can leave a little bit of a cleaner pocket. It also deforms slightly and goes into the flash hole, something that this metal one does not. It's flat because they don't want you to cut into that. So invest in lollies and you're good to go. The primer pockets on some brass, you may find them tight, or they're not quite as deep as they should be, or your primers are a mismatch with the case that you've got in terms of one has a tighter tolerance than the other. So you can get tools which I think at this level of reloading you're unlikely to need. This one looks a little bit like your case trimmer. It's got a 4-blade cutter there, and it is a primer pocket uniformer. So this has a specific depth set to it, and it allows you to bottom it out in the primer pocket, give it a quick turn, and I can feel it's cutting a little bit out already, and there you can see it has put a slightly shinier point on the base of the primer pocket. Indicates that maybe the primer pocket, the floor of that was not particularly uniform or flat. Yeah, looks very uniform now. The excuse the phone call. The need for uniformity in this is based a lot on assumptions being that all these holes need to be the same size, all these pockets need to be the same depth, everything needs to be uniform, all the cases need to be sized the same size. The more things we get uniform, the more variables we can remove from the case itself, and therefore increase the accuracy of the ammunition that we're making. So that is one tool that faces off the bottom of the primer pocket. There are other tools available that allow you to uniform the side of the pocket. Some brass you'll find, if it's factory ammunition that you've shot and you're using once fired brass, you can get brands of ammunition where at the very edge of the primer pocket here you'll see a little lip, and it's because the primer that was set in the factory has had a crimp applied to it on the very edge of the primer pocket itself. Now those will deprime when you resize the brass, and the primer will pop out, but when you come to seat a new primer you'll find it quite tricky. It's a bit stiff, it won't necessarily go in square, you might get them tearing on the edge, and it can be a bit of a pain. So you get a swaging tool which just removes the edge of that crimp that's been applied and allows you to then complete the reloading process as it would if you bought brand new virgin brass from any one of the manufacturers you can get brass from. So we've done primer pockets, they're nice and clean, they're all uniform. What next? So there are other stages that you can go through. The sizing that we did on this particular case, if you remember, was a standard full length die. Case goes in, the neck of the case is compressed to below the size that you require, and then the expander ball on the end of this pin here is dragged through the neck and pulled through the neck to the size that you now wanted, roughly 2/1000 of an inch less than the bullet diameter. That makes a number of assumptions. The assumption being that one side of this neck is the same thickness as the other side of the neck, that is the same thickness from one end to the other, and that the material from one neck to the next in terms of the cases you have are uniform in length and elasticity. Now, you can't control an awful lot of that, but there are various things which will enable you to, again, remove a few variables and give you the confidence that you've done everything you possibly can to remove any variables from your case. So what I've got here is a handheld outside neck turner made by a company called Forster, an American company. A lot of our reloading equipment comes from the US. Arguably they are a little bit further ahead in everything they've ever done with this, and ultimately some of the tools they produce are very, very good. These are not cheap. It's a stage in the reloading process which I personally have never actually used. I've never really felt that I've needed to. If you go down this route, it can be very gratifying because you know that everything you've got is absolutely bang on and there are no variables at all. To my mind, that just leaves you as the variable, so when your groups are not as tight as they should be, you can't blame anything else because it's just you. And very simple bit of kit, aluminium block with a number of ports. This one is holding a pilot for a 7mm case. Now that could be 7mm Rem Mag, could be 708, or any 7mm case. Now there are graduations on this. In theory, each one of these graduations equates to 1/1000 of an inch. I'm sorry, I don't trust that. I wouldn't necessarily just start screwing it down saying, well, there you are, there's 2 more thou. I would want to be measuring these. Now you can measure the outside diameter of your case by using a dummy round. I think we did this previously when we were setting up a bushing die. A dummy round here, you know it's a 6mm bullet, or the actual measurements irrelevant. What you're measuring is the difference between the bullet itself, so that I've got the calipers just on the bullet there, and the neck. Now obviously you're measuring 2 sides of the neck there, so you're going to get 2 measurements. Now on this particular case, if I turn the case in the jaws there, it's pretty uniform. It's not actually changing a great deal. We're talking 5/10,000ths of an inch. Now on my Mickey Mouse 10 quid Aldi calipers, 5/10,000ths of an inch is not possible to read. I could do that just by squeezing the case and getting another 15 thou out of it. What I'm trying to do is just see if it does change, then I know there's a little bit of difference in the neck thickness. So what the neck turner does is this carbide cutter at the very bottom here can be set to a particular depth. Now this one has a slight edge to it. It's been milled down at the edge. Now that edge is designed like that to hit the junction of the neck and the shoulder perfectly. I've already run this case through. I did it on my electric drill. You can do it by hand. If you slide the case over, it's very tight fit on this pilot. These are sized cases. Obviously you've already completed the process of turning the inside of that neck to the diameter you need, 2 thou less than bullet or whatever the manufacturer set it to. as you drive this down and turn it, the cutter removes any high spots on the brass. Now, depending on how deep you set that cutter, it will remove more and more and more material. So if I can try and do this, if we zoom in on this case here, you'll see that the cutter, I did this a bit quickly and a bit rushed, so it's a bit rough, but you can see that there are dull areas where the cutter hasn't touched it. It's an obvious low spot. There are a lot of high points that are now shiny, and that's obviously where the cutter has removed material. Now, that's great, but my overwhelming fear is removing material from this case at any stage in the reloading, whether that be trimming or neck turning or swaging or anything else you want to go through, is removing material from something that you're reliant on being strong when you pull the trigger. So bear in mind that if you do trim to lengthen your full length sizing and getting a case to a particular size, overall length size, and then you're neck turning to get a specific thickness for the width of the neck, you are making the assumption that this neck is the same thickness and the same length. Therefore, if the next case is the same thickness and the same length, it will have the same neck tension. That assumption relies on the elasticity of the brass as much as it does anything else. There is an argument for neck turning. It's not necessary in most situations for reloading. Target shooters will go through a whole number of stages that we haven't covered in these videos to try and get uniform cases and to remove all those variables. But it's clear that this case had some high spots, so we could go one stage further and get to the point where it is all nice and shiny. I would argue that what I'm trying to do here is just make sure that I don't have a super thick part of the neck on one side and a thin part on the other. So there are a couple of different ways of doing this. Now, this works for cases that we've sized using a standard full-length die. We've sized the case to the inside diameter. We've sized the neck by using an expandable to the inside of the neck. So our neck tension has been set by the size of the hole inside this. The comparison would be if we use the Redding bushing die that we looked at last week, where this bushing die has been chosen for a specific inside diameter based on the measurement of the neck thickness itself. So this case has been sized into that bushing, and the bore of the neck is based on this size minus the size of the neck itself, in addition to the size of the neck itself. If we neck turn this, we're removing material from the outside, and I don't actually think you're helping yourself, because you're removing the outside material, and that is your reference point for the bushing itself. So there are other ways of neck turning. There are internal neck reamers that you can use, which are very effective, but again, I genuinely don't think that the vast majority of reloaders will see the benefits of doing that unless you are already looking to compete in F-class or bench rest, in which case you're probably long way ahead of anything I'm going to cover in these videos. But just very quickly, I'll show you something which is an antique by our standards. This is the Lee Target model, and the typography and the paperwork that comes with it should give you an indication of how old it is. So the Lee loader that we looked at last week, which was the most basic of all the reloading equipment. This particular one is no different. It comes with the single die that enables you to force the case into, this one's for treble twos, that's not going to fit. Force the case into the die, whack it in with a mallet until it's flat, and the only difference with this one is it comes with an inside neck reamer. So this reamer, very similar to the the neck trimmer and all of the other cutting tools, a multi-bladed, very sharp tool steel mandrel or reamer, sorry. This one is meant to be attached to this handle. I actually used to run it through the drill again. Once the case is in there, the outside of the neck is supported in the die. That's what the die has used as the reference point to size it down. This then drops inside and removes any material from the inside of the neck. Now, there's no slop in this at all. It's a very, very tight fit. The benefit there is you are getting a perfectly uniform outside neck diameter because you forced it into the die. You're getting a perfectly uniform inside neck diameter because you've cut it to, in this situation, again, 2 thou less than the diameter of the bullet. There is, in fact, a step just on the edge here, and I would probably say, if I measured that you'll find that the pin itself is bullet diameter and the reamer is only removing material down to the point where it's just 2 thou lower than the bullet diameter. It's a very advanced way of hand loading, and arguably it produces some very, very accurate ammunition. It is a bit mundane to go through the whole process of 100 cases, whacking them through this and then whizzing them through the neck reamer. It also leaves you with cases that, if you were then to put them in a standard Lee loader, because there's a difference between the inside bore of the neck element of this die and the standard Lee loader, which was this one here, if you remember, they are not compatible. So you need to choose which one you're going to use and stick to it, which I obviously got bored of and moved elsewhere. So again, you can spend lots of money on inside neck reamers, outside neck reamers, and get nicely shiny necks like this, which you know are probably more uniform than they would be if you left them as standard. I'm not going to tell you that you all need to go out and start buying these things, because I generally don't believe that there is value in them at this level of reloading. We're not trying to compete with 1,000-yard target shooters. We are looking for an affordable way of reproducing factory ammunition that ideally will be more accurate than the stuff you've been buying off the shelf. So the next thing I wanted to touch on is annealing. This case, as you can see in the shell holder here, I'll try to show the colour change on the neck. Around about here, I'm not sure if it's showing up on the camera, you can see that there is a slight colour change. So this area forward of that line there has been annealed. It's been heated up to a certain temperature, monitored very closely so that the temperature does not go past this point here. In fact, there's a brand new Lapua case where it's much more obvious, and you can see quite clearly where it's been annealed. Now, the manufacturers in this case have done that to make sure that the elasticity in this brass is as close to uniform as they can get, so that from case to case, in a brand new case such as this one, this will provide the same neck tension as the next one in the box. As you go through the process of firing, resizing, and continually working that brass, the elasticity of the metal disappears. In the same way that if you bend your knife and fork or fork and spoon back and forth at the neck, it will break. Brass will do the same thing. It's a little bit more flexible than your stainless steel or whatever the cutlery is, but at some point it's going to give up. Now, that's shown in a number of ways. You can get cracks in the neck where it's literally just expanded and given way, and you'll get a little crack here, and that is quite extreme. I was sent a load of photographs from somebody just recently, which I'll try and find on the phone at the same time. But the most common one is that the neck will not seal in the chamber, and you will get a number of symptoms. The black soot mark that you get on most cases, try and find one here. So there you can see around the neck there is soot. It is shown primarily because the case is sealed there in the neck, and the gas pressure cannot go any further, but it has left residue of where the soot was in the chamber and on the edge of the neck there. It's not, as you may see here, a uniform ring. It's at an angle. It's sealed much tighter at one edge of the neck here, and then it's run all the way down the neck there. Any further than that, I would be getting concerned. Now, these cases happen to be mine. I would estimate they've probably seen upwards of 10 firings. Now, they've never been annealed. I very rarely trim, mainly because the setup of the dies and the process that I've done to reload these cases sees the brass move as little as possible. I'm going to switch the phone here and show you some photos of some cases that have not been annealed clearly. Now, these thankfully happened in the die as part of reloading rather than when somebody pulled the trigger. The neck is clearly very, very brittle. I would say an absence of lube, so use lube, everyone. The neck has just ripped off these cases, and they've obviously all been damaged. The particular person who sent these in didn't indicate how many times they'd been fired, but I suspect probably quite a few. So annealing can be done at home. It can be done on your cordless drill. It can be done with mini blowtorches. There are various machines you can get to do it for you. Ideally, you want to spend some time setting these up so that you're not heating the body of the case past this point here. This is the area that the manufacturer is expecting to have to go through work cycles, and this is the area of the case that the manufacturer is expecting you to be sizing. So every time there's a size, the work cycles it goes through, firing, sizing, you're trying to relieve the stress in the brass and bring it back to the elastic and springy material that you had when you first got the case and it hadn't been fired. So there are materials that you can buy that you paint along the side, which will change color when you get to a certain temperature, and they'll also change color as it goes down, as the heat goes down the neck. So you can set up the flame and the length of time that you put the case in the flame so that you're not cooking the cases. If they get to a certain point and you've gone too hot, you may as well throw them away because you've destroyed the elastic property of the brass, and it won't grip the bullet, and you will find that you will get more issues from that case than you will if you just left it alone. So there is an argument to when you should be doing annealing, and I noticed this online just the other day when people were talking about it. I'm not an engineer. I can't tell you what the case goes through in terms of the bigger picture when it's annealed, but to my mind, if I'm trying to set the elastic constant of a material, the annealing's the last stage I want to do. Now, this is a brand new case, never been fired, nice and shiny inside. It's been annealed as the last point of what it has gone through. Bearing in mind that this started life as a flat coin of brass. It was then stamped into a cup and then gradually drawn out into a long tube without a shoulder, and then the shoulder is sized into the case. At the same time, it's getting a rim and a head stamp put on it. So it's gone through a lot of work hardening in that process. They've then annealed it to make sure that you've got an elastic neck when you come around to loading this for the first time. So if it's good enough for the manufacturer, the annealing for me would be the last process I do. But there are a lot of people who are concerned that by annealing a size case, you may have changed the size of the bore and thereby the neck tension. I don't know. Arguably, I'm going by a process that the manufacturer is happy with, so that would be the one I'd be going for. If you were to anneal before the sizing process, you're then work hardening something on top of the work that you've just done to make sure that the brass is nice and elastic. So, personal choice on that one. I don't anneal anything. There are people who will do this for you, and services. It's very reasonable. You can send 100 cases away and get them posted back to you for roughly 15 quid, and they come back and they're all annealed on a machine that will provide you with a fixed point of temperature, flow, and it sounds like a much better option than doing it yourself, unless you particularly like sitting in a shed with a blowtorch. So annealing, we've got our cases, we've done all our neck turning, we've cleaned out the primer pockets, and this case is now ready to go. Or is it? So if you remember, we have forced it in here, and during the process we used one or other variety of lubes to make sure that the neck did not get stuck in the die, whether it's a liquid based lube or a wax based lube like this. It's still on this case, and we need to remove that for a number of reasons. Primary reason for me is that you're going to stuff a metal object into the neck of this and try and hope that all of the tension from this brass is going to be the same as the tension in the next one. If this one's got more lube on it than the next one, then you have a case which may release that bullet easier, faster than the next case. So we want to remove that. The most common form of case cleaner is the vibrating tumbler. These come in a number of forms. I've got a small one here. It's a rotary motor with an off-center cam on it, which just obviously vibrates, as the name suggests. Inside the container, you throw all your brass and some media. Now that media is usually organic. Walnut shell is quite commonly used. There are a variety of others. Corn cob. Organic ones, mainly because they're waste products from the food industry, and in theory they should be cheap, but for some reason as soon as you stick them on a reloading bench they become very expensive. That's what it looks like. You've got a granular based product. This one particularly is I think it's walnuts, but it just says nuts. It's powdered crumbled shell. It's obviously quite hard, but not hard enough to start removing the material from the case. There are cleaning compounds you can add to the walnut. There are all sorts of things you can do to make it come out so that your case will come out looking like this, but without the annealing ring, because you've removed that and everything is shiny and clean. Inside looks like this, and you can say, I've now got the cleanest, best sized case that I've ever seen, and it's got all the anomalies taken out of it, and it's the most uniform thing I can produce. I'm far too lazy for that shit, so I just give them a quick spin in the cordless drill. This, for the outside, is very good stuff. It is called 4.0 wire wool. It's very, very fine. It doesn't weigh anything. It doesn't feel rough. It is very good abrasive, and you can just whiz the neck in this, and by doing so you remove all of the tarnishing from the neck of the case, and the annealing ring will go away and you'll get rid of most stuff. It doesn't solve the problem of what about the inside of this case, but then, as we've already ascertained, I am particularly lazy, so most of mine are neck sized on a collared die, so I haven't used lube in the first place. So the inside of the case to me is not a concern because it's already clean and dry. Fired cases like this will obviously have carbon inside the neck. You can see inside there's a variable level of carbon. Now that creates a slightly rough surface. I don't see that as a bad thing. The super shiny ones you get once you've put them through a case cleaner, I'm sure that they produce the same kind of neck tension. And in my experience, I'm not seeing a huge difference in accuracy of a round because I've put it through a cleaning process that's added another 6 hours to my reloading. When actually all I'm trying to do is just make sure it's not covered in wax and sticky stuff, picking up dust when it's in my pocket and being dragged into the chamber. I'm trying to protect that chamber from any extra stuff that can be added to it, whether it be water or dust or grit or any kind of organic material. And obviously having a nice clean case that's got nothing sticky on it, it's not going to drag any of that into the chamber. If it does, when you pull the trigger, primer goes off, pressure reaches 60,000 psi or depending on your case, and anything you've got on the outside of this case is now hammered into the wall of your chamber. If you keep doing that, you'll find that when you bore scope the rifles, you can see that they start to pick up grit, they start to have corrosion present, and then you get to the stage where the imprint of that chamber is now left on your case. So your case doesn't look smooth and shiny, it's got a kind of orange peel effect to it. Any imperfections in the outside of your brass are usually from the imperfections in the inside of your chamber. Obviously your chamber's steel, your case is brass. This is much softer. It's going to take on the imprint like a bark rubbing with a wax crayon on a piece of paper. The concern there is if your chamber is rough enough that it grips the case too much, then you're going to get difficulties with extraction, unless your brass is particularly elastic and is springing away from the neck after it's cooling and after the shot's gone off. You need to have that elasticity, otherwise every time you try and eject the case, it's going to get stuck. We had a rifle brought in just recently, and the customer complained that these loads were very hot and he was getting a sticky extraction. When we bore scoped the rifle and we looked at the cases, that was not the case. These were factory loads, they weren't hot at all. What was happening was the neck area was filling in voids in the chamber, and the case just would not come out. We had to put a cleaning rod down and knock them out from the inside. So keep the cases clean. Anything you have on the case when you chamber it is going in the chamber. You don't want that. You want them nice and clean. So vibratory media cleaners are one. An alternative which I had forgotten to bring with me today to show you are ultrasonic cleaners. You can get these very affordably from the big supermarkets, Aldi, Lidl, Asda, all of the big brands. It's a box. It's not very big. It's probably less than 12 inches long. Usually they take about half a litre of liquid. The cases go in the liquid. Turn the ultrasonic cleaner on. You'll have seen these for cleaning jewellery. Your dentist has them for cleaning his tools and equipment. The machine vibrates the material in the water at an ultrasonic frequency, which one advantage there is it will clean out the primer pockets because it literally vibrates them to the point where the carbon will fall away from the inside of the neck. Same deal on the inside. They are a lot smaller than the media and vibratory tumblers. The advantage there as well is you take them out, give them a rinse under the tap, put them somewhere warm, let them dry. That's it, clean. With the media tumblers, bear in mind that when you've done cleaning, all your cases are going to be mixed in with a bag of this stuff, which is now turning black because of all the carbon and the oxides coming off the outside of the case. You have to sift the cases out of that, and in certain cases you have to wash them because they're now covered in dust and powdery stuff that you want to get out of the case. So again, to keep it simple, I have not gone down the route of using vibratory tumblers. They're a bit of a pain if you ask me, but they are very popular, and you do get very nice, shiny, squeaky clean cases that you can show all your friends and say, these are my nice, shiny, squeaky clean cases. Ultrasonic cleaners do the same job. You won't get the shiny surface there. It comes out with a slightly dull exterior, I would say almost like the annealed section of this case in terms of colouring. I couldn't care less what colour they are, so long as they are well sized and do the job. That is the probably the second most common case cleaning kit. The alternative to that is stainless steel pins in a rotating tumbler very similar to some of the things that you might have seen for polishing rocks. It's a rotating drum where you load all your cases in with stainless steel pins of a certain diameter to make sure they do not fit either sideways in the primer pocket or sideways in the neck, and that if they do go inside the neck, they do come out. I've had one of these things, and to be perfectly honest, I stopped using it because I did get two of the balls that got wedged side by side in the primer pocket. I also got one that got stuck in the case itself. Again, individually checking each case to make sure it hasn't got a stainless steel pin in it before I then put it in my rifle is one stage I couldn't really be bothered with, because ultimately I'm not that fussed if this case is super clean. They are very good. They are noisy as hell, so do put them in the shed or the garage, otherwise someone's going to be shouting at you for the infernal noise coming out of your reloading room or wherever it is you choose to reload. So it's now squeaky clean, size to the size we need it, trimmed to the right length, pockets are clean, everything else. So the next stage is you're going to start building that case up. So the first process you're going to go through is you need to replace the primer. Now there are a variety of brands of primers. This one, CCI, very large brand. They obviously make a lot of rimfire ammunition as well. They come in all sorts of shapes and sizes. These are in a flat tray, and the primers are oriented so that they're either face up or face down. Federal, for example, is another brand which I'm not going to pack it off here. The primers are oriented on their side. I don't honestly know if there's any safety precaution about primers being flat, pointing away from each other, or on their side, but the packets are very small. Don't drop these. It is very annoying to go on hands and knees to try and find them, and there are probably several hundred on the the floor of the shop from previous efforts here. Doesn't really matter from my perspective whether you go with CCI, a Federal, a Remington. We have a lot of primers coming in from Russia and various Eastern European countries. Muron are one brand that comes in from the Eastern Bloc and have had very good reviews. Ultimately, I do not feel that the primer impacts my accuracy as much as other elements of it, so it's not a major concern when I choose a primer. I'm looking for one that I can get reliably and is giving me consistency. So consistency in that sense, I don't want to be getting any misfires. If you go online, you'll see instances of misfires from various brands, and people will attribute it to the brand of primer rather than anything else to do with their reloading or the hardware, the rifle itself. If we get rifles being brought in with misfire problems, or shotguns even, the first thing I'm not looking for is what brand of primer they are using. I'm looking for something more physical in the setup that will be causing this more often than the primers themselves. Packet of primers can be as low as £4, £3.75 for your Russian specials, right the way up to £6-7 for premium Magnum. All of these brands also do a match grade primer, which allegedly is slightly more consistent than the one you've just spent £5 on, but I can't shoot well enough or load in a detailed enough manner to demonstrate the difference between one to the other. But again, this is not about how consistent your reloading is. A lot of it is down to making sure that when you lie down behind that rifle, you have removed as many variables as possible so that you are utterly confident that when you point that rifle in the direction you want it to go, that ammunition is not the limiting factor. The ammunition is consistent, and you've done everything you possibly can to make sure that you've ruled out any anomalies or variables. So we've chosen our primer. Find one that you can get rather than one that looks good or a box that's the colour you particularly associate with. The CCI at the moment we're struggling to get in any volume, just because I would imagine they're US made. We're getting a lot of people buying primers and ammunition in the US, and we are a very, very small market compared to their home market, so we just don't see them. I'm speculating, but ultimately that's what happens with a lot of US-led products. We've got lots of other US brands which appear to be less popular, and we are seeing more volume coming through to the UK. So find your local gun shop, see what they've got, choose one and stick with it. If you do decide to change primer, every reloading manual in the world will tell you you will need to work up that load again. Change any component in the reloading process, work up from the beginning again. These cases are all the same. Triple G, I can be fairly confident they've all been fired the same amount of times. I know that the volume inside this case is the same as that one, or close enough that it won't make a blind bit of difference to a shooter like me. If, however, I was to suddenly chuck in a load of PPU, and there's a Triple G and there's an RWS, and I start loading all three of those, you can be fairly confident that each one of those has a slightly different internal volume. As pressure, which is what you're trying to generate with your powder and primer choice, is entirely dependent on volume, you are going to get different pressures from these. You're probably going to get different neck tension because the thickness of the neck will be slightly different one to the other. The quality of the brass will be different from one to the other. Everything will be different. So change the brass, work up. Start from the beginning again, go through your load data and work up to find an accurate load for that. Change the primer, same deal. I wouldn't have said it's as significant as if you start changing to a different brand of case, but it's significant enough that I would want to be sure. And the only way to do that is by going from the beginning and starting all over again. So priming tools come in all sorts of shapes and sizes. Get this brass out of the way. This is the vintage priming tool that came with my Lee target loader. It's a single primer, very straightforward. Take the primer and fit it into the primer hole, making sure that it's pointing up. Now the anvil there, you can see inside is a metal, triangular piece of metal that's independent from the primer cup, which is the outside, and that's obviously the bit you want on the inside of the case. So point these up and it's going to be forced into that hole. These are quite handy, apart from the fact they're extremely small. They're all metal. There's nothing plastic on here to let go, and the priming process is very straightforward. I'm just going to squeeze that. I'm using two hands just so I don't wobble in the camera, and it's not a huge effort. That primer's gone in very easily. In fact, I would say I've probably actually gone a little bit too far on that one. It's not an issue, but as you may be able to see, this primer is now a little bit sunken in that primer pocket. So long as it's not protruding, doesn't matter. The major concern with primers that are protruding is the cup itself doesn't have enough body in the pocket, and more importantly, because your headspace is determined by the amount the case goes into the chamber, if you've got a primer sticking out too thou on the bolt face, that's going to interfere with the headspace measurement that you've so tirelessly worked to make uniform in your die setup. It's not a major issue that this is slightly sunk in the pocket. If you remember from the beginning, the process when the firing pin hits it is going to drive that primer into the primer pocket anyway. As it does that, it's all in a split second, pushing the case neck and shoulder into the chamber where it bottoms out, and as the primer ignites, the pressure builds up inside, the neck seals, the primer actually backs out of the case, and the case will grow back onto it. So you'll see on cases that have got primers still in, there's one that's fired, more often than not they're absolutely flush with the base of the head of the case there, and there's no lip there of any consequence because it's gone back. The case has forced the primer back into the primer pocket on the bolt face, which is a uniform flush surface. And this one was a little bit hot, as you can see. There are some marks here where the extractor and the ejector groove on the bolt face have left marks on this case, and this one, I think we showed you in the first video, is very flat. It's not completely flat, but it's a sign that I've probably gone a little bit too high on the powder charge when we were working up a load for this particular rifle. Unusually, everything else in this box of 100 was fine, with the exception of 3 cases, which I can't comment on because I don't know the reason why that one was particularly hot versus another one. I can assume that potentially it had slightly more powder in, and it was close enough to the limit that it just put this one over the pressure limit. Wasn't a major concern. The bolt was not too stiff when it lifted, but this is certainly, if you look at the edge of the case, edge of the primer there, it is pretty flat right the way up to the edge of the primer pocket. There are flatter examples. If you can't see the line between the primer pocket and the edge of the primer itself, then you've got really, really high pressure. This one is just moderately warm. So we've just forced that one into a case with a single priming tool. Vintage things, you won't see these very often. What you will probably have, or will see in most kits, this is the older style round hopper version. They now come with a square hopper like this for the primers, or if you go with the Lee products, they have redesigned these to a folding square hopper. The idea being that you can take this, you can put it over your tray of 100 primers, flip it over, and all your primers are nicely sitting in the hopper there. If you notice that these have ridges all the way along, these are designed that if you shake the primer back and forth, shake the hopper back and forth, all the primers will upturn the right way up, and then you simply just close the lid and lock it in place. And these ones, if you give it a bit of a shake, lock it in place, give it a bit of a shake, and you can see the first primer has already come down the channel, ready to go into the area where it is going to be seated. They're getting more and more ergonomic in the way they build the handles. This is one, I think this is an Ergo Prime, there's an Auto Prime, and various other models from Lee. All the major manufacturers make them. Step away into the bigger names, and you will find that they become more and more expensive. The only advantage of the Lee stuff is, apart from being cheap, all of the individual components can be replaced and the spares are readily available. It's not always the case with some other makes. I will just try and do this without unhooking the phone, but here we have a bench-mounted Lee. It's identical in form, but the only exception is it's screwed to my reloading box, and the handle to operate it is a little bit longer. The advantage there is because you're not holding it with one hand and squeezing it and having to feed everything in, and you can get through a whole load of cases a lot faster. The only disadvantage with the handle being that long, it's quite easy to break it, especially if you've got a ham-fisted 15-year-old who was tasked with loading 1,000 rounds the other day and smashed the ram in probably his second go. So these are cast materials, not just because they're cheap, they are consumable. They're designed to break. They want you to break this before you break the handle, or the primer goes off because you forced it in with the force of a gorilla. So those are quite handy if you've got a bench that you can dedicate to reloading, and you can screw everything down. It's nice and solid. One other option is the press itself. I'm going to take you down here for a second. This press has an arm that you can see is located on the edge of the ram, and that is obviously your cup for putting the primers in. The advantage here is you're doing it as part of a bench mounted press process. The disadvantage in my mind is you've got a 12 to 18 inch arm that allows you to put an awful lot of force onto that primer. Now these primers are very thin. If you do put them in sideways, they will go in, especially if you've got a tire iron length arm for the press to allow you to put that leverage through the ram. This works on the basis that you, as you can see, as you drive the ram up, it is taking the case up into the die that you don't have in place, but to size it or deprime it or to whatever you do, you've by hand popped in a primer into the cup just here. This is obviously set up for small rifle primers, the smaller cup to take things for 222, 223, those kind of cartridges. As you bring the ram back down, the mechanism pulls the primer assembly back into the ram, and you get to this stage with the arm, and as you push the arm forward, it pushes the primer into the case, and you then obviously just slide it back, take the case out, and that's you primed. It can be useful if you're doing this all in one process, i.e. you're doing one case, you're sizing one case, you're priming one case, you're loading one case, and doing it in that method. I prefer to do everything in one stage and do all my cases to that stage. So I size 100 cases, I will trim 100 cases, clean 100 cases, have them all in the box. I will probably have put them in a tray, which rather irritatingly does not take 100 cases but takes 80. Whoever designed this needs a slap. Anyway, and once I've done that, I can look at all the cases and say, well, I know every single one of those cases has been sized. My brain doesn't work in the whole cycle process of doing one case from start to finish and then doing the next case from start to finish. I want to go through and have all the kit for priming in front of me and do all the priming, all the kit for cleaning, trimming, whatever, and get that process out of the way. How you do it is up to you, but I would certainly recommend that if you do go through the process of the full cycle on one case, that you have some way at the end of double checking that you have put a primer in, put the right amount of powder in, and sat the bullet to the right depth. Whereas if you do them stage by stage, you can say, those have all been sized. It's very clear they've been sized. They've got no primer in them. Those have all been trimmed. It's very clear they've been trimmed because now I can see the very shiny point at the neck that I've just cut into it. I can check they've all been primed. I can put them all in my tray. When I powder charge everything, I can look at the top of the tray. I can look down into all the cases. They sit in the case like that. I can look in them with a little torch and I can see everyone's got powder in. If there's one that happens to be brim full, then I'm thinking, well, that's a different level of powder. I've excluded that from the process, and it's a constant quality control and check of my process. I have to be honest, it's not unheard of me pulling the trigger on the firing point of a range, it going click, and me saying I've got a misfire, only to find out that actually what I have got is a primed and seated bullet in a case that has no powder. It happens. I'm not proud of it, but it's a consequence of maybe rushing the job or getting distracted halfway through. Maybe I've stopped for a coffee and I've loaded one, not put the powder in, it's gone in the tray, and I haven't completed that check at the end of the powder charging to make sure that every single one of them's got powder in. So bear that in mind. If that does happen, it's not the end of the world. On this particular case, my neck tension is strong enough that the bullet does not leave the case. The primer itself in a large case will not put enough gas pressure into the case to discharge it without the powder. So you just find that you've got what looks like a misfire, but give it a shake and you know there's no powder in there. Unless you are running compressed loads, in which case there's nothing to rattle when you shake the case, it's not a problem. You won't see a major issue from forgetting to put the powder in. So covered all the primers, the various tools you can use. In terms of how you go through this and check, all I want to make sure is that when I run my fingernail over the end of this case, there's no lip of the primer sticking out proud. I want it to be flush ideally, and I want them all to be flush in the same same level. These you'll get to feel very quickly that when you put a case in to a hand primer like this, when you'll get to a stage where you think, oh, that one's a bit tight. Just check it hasn't gone in sideways or squint. We had a couple of primers that we put in just recently in cases, particularly PPU cases, which are usually at the very high end of the spec for both size, overall length, and the tolerance on the primer pocket. They're quite tight, they can be. If you choose a primer brand which is known for being at the other end of that spec and is quite large, then you're going to get interference. And we were removing brass with the primer, and you could see the little lip of the brass that had been chamfered out by forcing the primer in. That was immediately felt in the hand primer, and we can check it, knock the primer out, swage the primer pocket back to a uniform size and reprime it. I'm not sure I would have felt that had I been using an 18-inch press arm to drive those things in. You would not feel the sensitivity in the arm, and that's one of the reasons I tend to use a hand primer. Bench primer, it's still pretty good. You've still got a bit of feel in that primer tool. So these, it's a bit mundane. You will get cramp. The advantage of some is you can turn them around, do it a different way, use your thumb instead of using your fingers to squeeze the handle. But ultimately, they all do the same job. Some are better for the actual primer handling, the ability to put 100 primers in a tray and get them all loaded up. One thing most of the manuals will tell you about primers is try not to pick them up and touch them like I just have, because any grease oils or just natural body oils from your skin in the primer will affect the way it goes off and the way it burns. Again, it's a variable that's small enough that I actually don't think it's a major concern unless you've got particularly greasy fingers or eating your fish and chips at the same time. So, good thing about the tray is you can just tip the primers in or put the primer tray over the primers, flip them up. You haven't actually touched any of them. It's only when you drop them on the floor, which will be inevitable, that you have to pick them up. So they can be fairly dangerous. They do advise wearing eye and ear protection. If you look at the clearly American made, the health and safety advice with these things is if they do go off, it's very loud. I did set one off by accident the other day, and yes, it was very loud. If they do go off and they're not supported in a case or by anything on the bench, they will go flying. Hence the reason that they suggest you wear eye protection. I have not had that. It's probably only a matter of time, but be advised, they can be quite nasty things when they do go off. So we've been left with nicely new, sized, trimmed, polished, cleaned, and now primed case. Again, my next stage would be to have all those cases in here. By removing them and putting them individually, if I've started with 100 cases, despite the idiotic 80 case tray, if I've got a 100 case tray, I know that if there's 100 in there, I haven't got one under the table somewhere, I haven't dropped one. If I've got a tray of 100 primers, then if I've got one left and there's 100 cases in here, then there's a rabbit off somewhere, I better start checking. Very simple. I haven't put any powder in this. I can give it a quick turn, see if it's got a primer in it, and leave it there for the next stage. So there are a few things that you're probably going to have to do, make some decisions on the products that you want to reload with. A lot of people start reloading with used brass from factory ammunition that they've fired in their rifle. That's a very cheap and affordable way to get into it. You've got the brass already, you know it fits in your chamber. There are some things that you can exclude from the process. You could maybe jump in and neck size, you could jump in and buy a 30 quid Lee loader and whack them in with a mallet and get decent factory spec brass. It's only been fired once because you know it has, because you bought it new. The advantage of some of the premium brass that you can buy brand new, for example, a box of Lapua brass here, is you will get a very, very high quality case, very uniform. It's already been annealed in the factory. These cases are expensive for a reason. They will expect you to get a long brass life out of them if you look after them and stick to your reloading fundamentals. But for the average reloader, there's nothing wrong with using your RWS in this case, Triple G or PPU in this case, brass. They are all capable of being reloaded. You will see anomalies in one brand to the next on how many times you can reload them or how quickly the work hardening happens. That can be as much a fundamental of your reloading technique and the level at which you're reloading as it is to the quality of the brass. But next choices you're going to have to make are, what powder am I going to use? So in the same sense that I choose primers based on what we can get, when I was shopping as a consumer, it was a major concern because I want to make sure that I'm getting the same primer next time around, so I don't have to start working up and doing all this shit all over again. Once you've got your load and you've got data on a particular load that works in your rifle, is accurate, gets you the velocity that you want, make sure it's written everywhere. I've got stickers on the press, I've got little books, I've got pieces of paper inside the die box which tell me exactly what load, what charge, what primer. So in the same sense as you've chosen a primer that you need to be able to get on a regular basis, we need to choose powders on this basis as well. So we have a couple of brands in the UK which are made in Europe, Vitavuri and Reload Swiss. They're both readily available. They both come in kilos. The other brands that you can get come from American firms like Hodgson or Alliant. There are Australian companies that make powder. Again, they're all within reason, readily available. We have in fairly recent times gone through a big change in availability of powder in the UK, which has seen the banning of a number of powders which were very popular in the UK. For example, Hodgson Varget, Hodgson 4831, Hodgson 4350, a lot of Hodgson. The main reason for this is a European legislation which has been in place for some time, but there was a deadline for removing a compound in their powder called 2,4-dinitrotoluene, which is a carcinogen. Obviously, we can't have carcinogenic compounds in products which we're actively using, especially if we are burning them and probably inhaling them. I can't comment on whether it's a major component of the powder or the risks associated with it. They're still readily used in the US, which is interesting given their health and safety and litigious culture. It doesn't matter because we have, in these two brands alone, some of the best powders in the world available on a readily available basis. The other advantage is because these come in kilos, depending on which location in the country you are, you could be paying anywhere from 75 to 110 pounds for a kilo. 110 was up in Inverness just recently, I noticed. On the whole, they're about 80-85 quid a kilo. If you're loading 308 or 270 or one of the larger bottleneck cases, you're likely to get somewhere in the region of 300 to 400 rounds from a kilo of powder like this. So it's not a huge investment. 80 quid is going to see you some time. Your primers, you're looking at anywhere between 5 and 7 quid a tray of 100. It's not a majorly expensive part of the process. If you're using used once fired factory brass, then you've eliminated that from a cost as well. The next component choice you have is obviously bullets. Now these are decisions we can help people make depending on what their needs are, and there are a variety of brands that we have in the UK that are also readily available. Hornady, big US maker of bullets and reloading equipment. Sierra, again, US manufacturer. Norma, part of the Namo group, which make a variety of other components and ammunition. Nosler, then some major manufacturers for target bullets, Lapua for example, and you get on to lots of boutique companies that will make bullets that are very, very good, just not in the volume or at the price point that you can get with the ones in front of you. Norma are a premium bullet. They are by definition quite expensive. I will remove those from the equation. On the whole, I think the majority of people are shooting Sierra or Hornady. They are very good quality bullets, and they're fairly affordable. Sierra have been cheaper for some years, only recently through hiking in pricing and exchange rates are they getting back up to the same sort of level as Hornady. Nosler, again, very good high quality bullets, a little bit more expensive. They all come with their pros and cons. A topic of discussion for a much more dedicated video is bullet choice for your particular discipline or your particular scenario. If you are looking for an all-round bullet that does everything from plinking steel targets or paper right the way down to shooting game, quarry, foxes, vermin, whatever it is, there are more bullets and makes and manufacturing techniques than you could possibly want to choose from. Not all bullets will do the same thing in all targets, and that's a concern that you need to address when you make those choices. Anybody who shoots deer in the UK is probably well aware of a move to non-lead ammunition to improve the quality of the meat that's going into the human food chain. It's not mandatory unless you are shooting on certain public sector ground, or you are selling into dealers that will not take lead shot venison. There are a variety of choices there also, and they don't need to be loaded in any way different to a lead core, cup and core bullet, but you need to choose your bullet for the application, the cartridge you're shooting, and the terminal and muzzle velocities you can expect from that particular cartridge. So we've got all our cases in here. Let's say we've done our 80 because we haven't got a tray that takes 100. We need to figure out what next. So we've chosen our powder. We've gone for one that in the load data, so for example, load data is freely available. You can find it online. This particular example, Lee are very conscientious in providing you with a huge range of powder choices. So if we look in this column here, we've got the powder type, various different brands. H tends to be Hodgson's, IMR, another big manufacturer, Reloader, made by the Alliant company, Ramshot, Ramtac, and you just keep going down the list. What you will probably find in an American-made dye manufacturer or a load book made by an American maker, you'll get a lot more American powders. So for example, you don't see any Reload Swiss in here. There is some Vitivuri, tends to be at the heavier grains, heavier bullet weights, so there are plenty of options. If I'm looking for powder data, I don't go to the dye manufacturer. I don't go for the bullet manufacturer. If you're looking for powder data, go to the powder manufacturer. They're the people that know more about your powder than anyone else. Why would be asking anyone else? So if you go on the Vitivuri website, it will tell you load data, rifles, pistols. Choose your cartridge, find your bullet weight. Now what you may find, like we saw in the first, and we covered it very briefly, if you excuse the lack of printer or ink in my printer, this particular bullet weight, 90 grains, same powders, and they've started with slightly different loads. That's a guideline. Their rifle, their brass, their primer, their barrel length, their temperature, and all of the environmental stuff that they've had when Vitivuri did this is producing the data that they're showing you here. It's a guide. You need to work up to make sure that your rifle, your brass, and everything else that you have in variables is producing safe pressures, hence the reason we work up on those charge levels. So I'm not going to go through the how to choose a charge level. I'm just going to cover the basics of your options for weighing, and then if you want to, we can do an episode specifically on building up a load. This is at the moment just fundamentals of how do I weigh or measure more specifically the powder that I've chosen into that case, so that I'm not going to blow my fingers off. We've chosen this one. Scales are the predominant source of measuring. If we remember, the Lee kit comes with this scoop. It's a volume measure. No factory ammunition has the powder weighed into the case. It's all dropped in by volume. So on the strength that they know more about loading ammunition than I do, it's safe to say that you can choose a volume measure so long as you have got corresponding data for that volume. Lee are very good with this. They do advocate using volume. So Lee Dipper, this one is a 2.8. It has the dipper size. There's a 2.8. I can use this dipper, throw that powder, and expect to get this velocity from that bullet. They know that this data is safe because they've worked it up. They also know it's safe because they've probably backed it down a bit before they published it to make sure that somebody doesn't have a very, very thick brass case and environmental factors or component mix that will lead to the pressure being higher than they're stating. They can't be seen to be publishing data that could anyway injure somebody through misuse. So Lee dippers are probably the most basic powder measure you can get. If you go online, you'll find there's an awful lot of old boys who've been reloading since the 1900s who've taken a brass case and cut it off at a particular level. So if they're loading for 308, they've worked out that this volume of powder up to the neck of a case that's been chopped off is exactly what they need. They've then soldered it onto a little handle, and they're using the case as a dipper. Very basic, very repeatable. If you follow some processes in actually filling the dipper, you can throw very, very accurate and repeatable weights and loads by using a dipper like this. You can buy kits of or 20 odd dippers of different sizes, mix and match, pair them up one to the other to get a range of volumes. Probably the most common starting point is a beam scale like this one. Again, this one happens to be from Lee because it was sitting in a kit over there. There are a variety of other manufacturers, RCBS, Lyman. They all produce a bench beam scale like this. Very straightforward. This one has an adjustable ball bearing, which if you roll it corresponds to a number here. In order to get that beam to level, I'm going to have to put at least 70 grains in here, and then there's a fine-tuning slide on here which allows you to tune the increments between 70 and 60 or 70 and 80. They are very accurate. I find them a little bit fiddly. I have done enough reloading now that I know the difference between 45 grains and 45.2 grains is not enough at the loads that I'm using to be dangerous, and it's certainly not enough to produce one bullet impacting the target 2 inches away from another. On the whole, if you were to shoot all the bullets from this charge level that we worked up in the first episode, from 35 grains up to 39.5 grains, I'd be very surprised if they didn't fit inside a 2 to 3 inch circle. What you'll find is that as you shoot, you'll find little groups of each one circling around the bull. If you can demonstrate that, then you're seeing the timing of the bullet leaving the barrel at a particular point of the harmonics. But overall, this whole charge, all of those bullets would impact within a clay pigeon sized target at 100 meters. What we're doing with this is trying to find the one that produces the tightest group. That's usually what we're trying to achieve. So beam scales, very cheap. I think these retail at about 20 quid now. Higher end ones go right the way up into the hundreds. There are various bits of kit you can get. You can use little webcams that will line up with the pointer and show the image on a laptop screen, which removes any parallax error of you looking down. If I look down on this pointer from here, that pointer appears to be significantly below the marker, whereas actually if I looked at it from the level, it might not be as far away as I want it to be. So gadgets and gimmicks to help with that. Similarly, electronic reloading scales, again, very cheap, not a huge investment. As a result, you can be fairly confident they'll be accurate enough for your purposes, maybe not lab-based accuracy. This one indicates that it goes up to down to increments of 0.1 of a grain. That's bollocks. You'll be lucky if they will measure plus or minus 0.2 of a grain. But as I've just said, if you can get this to throw figures like 45 grains with a 0, you can be fairly confident you'll get to work with your electronic scale. What I find with this one, which happens to be mine, is if you allow it to settle, when you've thrown a weight on there, it's moving around because I'm moving, but if you throw the weight on here and just give it a bit of a tap to go past where it should do, it will come back. It will throw very, very repeatable weights using this for a 20 to 30 pound electronic scale. Again, a little bit of aluminium cup. All these things that are in touch or in contact with the powder, don't clean them. Leave them with some powder residue on them. It keeps the static electricity away from holding on to the kernels when you tip the pan into the powder funnel. So in those scenarios, whether it's the beam scale or the electronic scale, we've thrown a powder charge. We have got it in a small powder pan like that, and it's simply a case of pouring it into the case. If these are brand new, you'll find that kernels will stick to the inside because of the static electricity. The best way to get rid of that is wash them with just washing up liquid soapy water and let it dry naturally. Don't rub it. By rubbing the plastic, you're putting a static charge into it, even just with your bare hand like that. If you let it dry by itself, the first powder you put through, any powder residue will adhere to the inside, and you'll see that, that's not a good example, but you'll see that that residue is what stops the kernel sticking to any of these plastic or aluminium components. There are one other set of measuring tools, and that would be these. So every manufacturer produces a powder thrower of some description. They are, again, volume-based powder dispensers. I think they're fantastic. They're very repeatable. If you were to weigh each charge that this cheap and cheerful 20 quid item throws, you'll see that actually it is within 0.1, 0.2 of a grain every single time. More often than not, it's identical. There's no variance at all. The way it works is the powder gets chucked in the top. This particular one has a nice way of, if you twist the neck, you can open the bore. If the powder hopper's full, you twist the neck again and it closes it off, which enables you to take this off, put it back in the bottle. Don't leave powder in these things, because you'll come back to it in a week's time and think, shit, what's in there? Especially if you're loading more than one cartridge and have a dozen different bottles sitting on a shelf. Every time you finish, take the powder out of this, put it back in the bottle, for two reasons. One, you know exactly which powder goes in which bottle, and two, this is not a sealed container. Even with a press-on lid like that, your powder will go off, and it is a product that does not respond well to being left out in the open air. So the way this works is fill the hopper. In this, the volume reservoir here, you can adjust the depth at which this plunger goes in and change the volume. As you do this, the powder runs into the volume reservoir. As you push it back up, it runs out the spout. Now you can pour this into the pan from your scale, or the pan from anywhere, or literally it's got a spout that is designed to take the case, so that you can throw the powder straight into the case. Once you have worked up a load and you know the powder level, set this ring, make sure you're getting the same volume and the same weight, whichever way you're doing it, of powder. You can be fairly confident you can throw these straight into the case and speed up the whole process again. I've just done 100 rounds of one cartridge that I shoot, and it is to the stage where I don't even go and weigh every 10, every 20. I'll probably weigh when I remember to get round to it, and they're accurate enough that once it's set, you can just forget about it. Always check when you start to make sure that it's still set where you wanted to set it, and you can have all the data you've got with your dies or your brass or whatever, wherever you want to keep it, to make sure that you've got the same charge level each time you do it. But very affordable and a very accurate way to do it, and for me they just speed the whole process up. So I'm going to wrap it up there, mainly because it's Friday night and I need a beer, but it's got us to the stage where we have pretty much run out of things to do with this case other than start seating the bullets in them, which we can run through on the next video, and I will go into the method of choosing the charge level and the working up the load that you will want to test in the field before we obviously seat the bullet. But for now, thank you very much, and if there are any of you still asleep or still awake out there, I will answer any questions anybody may have. Please feel free to fire them through Facebook. This video will be uploaded onto YouTube again, and the link will be posted on our Facebook page. But enjoy your long weekend in isolation, and thanks for watching.